Think about the most terrifying thing in the three-body problem. Is it the droplet or the dual vector foil? No, it's our own solar system. Like Trisolaran system, it's not a perfect clock. It could fly apart at any moment. If gravity flinches or a butterfly flaps its wings, your stable era could end. Humanity first glimpsed this abyss in 1889. That year, someone attempted to prove our universe was perfect, but tore open a crack in the fabric. The King of Sweden held a math contest. With one question: prove the solar system is stable. Prove Earth will never fly away. For Henri Poincaré, this seemed like a weekend project. Newton had solved 2 orbiting bodies. Poincaré thought 3 would be easy. He submitted his answer and won the prize. Everything seemed perfect. But just before the journal was printed, an editor pointed to a page. "Sir, is there a problem here?" Poincaré confidently picked up his pen, but he saw the chaos. It was not a small error. With 3 bodies pulling on each other, their orbits were impossible to calculate. Even a tiny change in the starting position would create wildly different paths over time. The idea of eternal stability was just a human wish. This is the 3-body problem. It is unsolvable, unpredictable. Because it is chaos, Poincaré faced disaster. Conscience triumphed over vanity. He spent more than his prize money to recall and destroy printed journals. He watched them burn. The solar system's clock was only temporarily intact. This math scandal didn't become common knowledge. Later, we invented computers. We thought it could predict the future. Meteorologist Edward Lorenz thought so too. He believed with enough equations, weather could be predicted perfectly. One day in 1961, he took a shortcut. He rounded a number from 0.50627 to 0.506, an extremely tiny difference, like a butterfly flapping its wings. He entered the data and went for coffee. He expected the same result as before, but the screen showed a disaster. That tiny error grew into a completely different storm. Lorenz stared at the screen. He realized that long-term weather prediction was impossible. The butterfly had flapped its wings. He later described it. A butterfly flaps its wings in South America and causes a tornado in Texas weeks later. When Lorenz plotted this chaotic data, he was stunned. The messy paths swirled around 2 points, never repeating, never separating. The shape looked just like butterfly wings or a deep eye. This is the Lorenz Attractor. It shows chaos is not random. It is a hidden higher order. Lorenz opened Pandora's box. Scientists found chaos everywhere, in heartbeats, in the stock market, in a dripping tap. Data we once called noise holds the butterfly. The harder you try to lock down the future, the more the fragile butterfly wildly grows. But was there a rule behind the chaos? In the 1970s, Mitchell Feigenbaum worked with a calculator. He wanted to know how order breaks into chaos. He saw systems move from order to chaos through bifurcations. One path splits into 2, 2 into 4, 4 into 8, into a dense web. He calculated the ratio between these splits, 4.66692. He didn't believe it, so he tried a fluid dynamics equation, still 4.6692. He tried an electronic circuit equation, still 4.6692. He had found a universal constant like pi. It turns out that chaos is not truly random. It has hidden rules. A dripping faucet and a raging river follow the same math when they break down. Meanwhile, Mandelbrot sketched chaos, fractals, and discovered chaos is infinite self-repeating entity. Zoom in on a rugged coastline. It still looks like a coastline. The Lorenz butterfly is made of these nested fractal shapes. Our world is made of rough fractals, from the edges of clouds to the blood vessels in your body. The simple rules repeated endlessly create infinite complexity. Back to the three-body problem. Liu Cixin turned Poincaré's nightmare into a funeral for civilization. Trisolarans used intelligence, linked brains into a computer. They tried to brute force the solution to the suns, but they failed. Lorenz's curse hung over them. A tiny error grows over time until the prediction is wrong. The three-body problem is unsolvable. This was a death sentence for science. It's why they invaded Earth. They wanted a predictable home with one sun. But is our solar system safe? Chaos theory says, not entirely. Over billions of years, the solar system is chaotic. Mercury's orbit could go wild. It might crash into Venus one day. We feel safe only because our lives are too short to see the butterfly's effect. The butterfly didn't destroy our world. It just reminds us, don't try to control the future. Learn to adapt. More importantly, life can only be born on the edge of chaos. Perfect order is dead. Nothing changes, nothing evolves. Pure disorder collapses. It can't hold information. Only at the border, in the space between the butterfly's wings, is there both stability and flexibility. Complexity emerges. Life can breathe. In the world of the three-body problem, civilizations are destroyed by chaos. In our world, chaos is freedom. Now the choice you make is flapping its wings, watching this video, holding on to a dream. You don't know what storm it will start, but you know it begins with you.